From the smallest of organisms to the largest of stars, the extent of the universe is something mankind has yet to answer. Although this seems to be the case, humanity has discovered that the atoms are the smallest component of every matter existing. The origins of the atom started out when Democritus, a Greek philosopher, proposed that all matter is made up of small indestructible particles called atomos, meaning indivisible. Therefore, he concluded that all atoms are hard particles with different shapes and sizes, but he could not prove its existence due to the lack of technology.
But the thought was also discarded, since other famous philosophers such as Aristotle and Plato had a more respected theory during that time. It was only after 2 millennia when Democritus' idea was validated due to an English chemist named John Dalton. Dalton's model of an atom is similar to a billiard ball. It also states in his atomic theory that all elements are composed of indivisible and indestructible particles. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms, and the chemical reaction is a rearrangement of an atom.
In light, in 1897, when J.J. Thomson conducted his cathode ray experiment, he discovered that all atoms contain tiny negatively charged subatomic particles, or known as electrons. He created the plum pudding model, which tells us there is a positively charged mass in the nucleus with electrons scattered throughout it, much like plum parts scattered throughout the pudding. According to this model, there would need to be tons of electrons in an atom to balance out the positive charge of the rest of the atom. However, when Ernest Rutherford conducted an experiment by firing a thin beam of alpha particles in a thin sheet of gold foil, Thomson's model was disproved.
Why, you may ask, based from Thomson's model, it was assumed that there was nothing dense or heavy enough inside the gold atoms to deflect the massive alpha particles from their paths. But Rutherford's gold foil experiment did not match Thomson's prediction, thus creating a new model of the atom. This model represented the atom to be much like our solar system, with the electrons orbiting the positive nucleus like planets orbit the sun. The nuclear model explained Rutherford's experimental result, but it also raised further questions. For example, what were the electrons doing in the atom? How did the electrons keep themselves from collapsing into the nucleus since opposite charges attract?
Luckily, science was ready for the challenge. Danish physicist Niels Bohr assumed that what if some aspects of atomic structure, such as electron orbits and energies, could only take on certain values. Bohr's atomic model followed Rutherford's planetary model. However, this model worked well for only the simple hydrogen atom, but it still showcases basic understanding of the structure of an atom. Since Bohr cannot explain all the behavior of electrons, in the 1920s, Erwin Schrödinger proposed that electrons travel in waves, which means their exact positions cannot be determined and rely solely on probability, thus forming the quantum mechanics model of an atom.
It is also known as the electron cloud model because each orbital around the nucleus of the atom resembles a fuzzy cloud around the nucleus. Orbitals are the basis of the electron cloud model of the atom, making this model accepted by scientists today. As a conclusion, from the ancient Greeks to the modern scientists, understanding what most things are made of is important in knowing the secrets the world has in store for us.